Good day viewers, welcome back to my YouTube channel. Today we'll be talking about random variables and probability distribution. A random variable is also known as a stochastic variable. It's a mathematical formalization of a quality or object which depends on a random event. Also, random variable is a numerical description of the outcome of a statistical experiment. In other words, we can define a random variable as a function that assigns a real number to each outcome in a sample space. Probability distribution is a mathematical function that gives the probability of occurrence of different possible outcomes of an experiment. Going back to random variable, we have two types of random variables. We have discrete random variable. We have continuous random variable. In today's video, we will be talking about discrete random variables. A discrete random variable is one which may take only an uncountable number of distinct values or numbers, such as 0, 1, 2, and so on. A discrete random variable has just two properties. All these properties are to be satisfied as far as the discrete random variable is concerned. Number one property, or number one condition, is f of x is greater or equals to 0. The second property or condition is summation of f of x is equals to 1. These are the two properties or conditions of a discrete random variables. A Bernoulli distribution takes an account of two events, 1 or 0, yes or no, success or failure. Bernoulli distribution has a PDF of f of x p raised to power x q 1 minus x, where x ranges from 0 to 1. Of course, we're talking about two events, 0, 1, success or failure, 0 elsewhere. Bernoulli distribution has the mean P and variance PQ. In this video, we will be proving the mean and variance of a Bernoulli distribution. Up here we have the Bernoulli distribution. P raised to power x, Q raised to power 1 minus x. Of course, our P can also be in this format, 1 minus P. Since Q is equal to 1 minus P. This distribution can also be written as P raised to power x into bracket 1 minus P raised to power 1 minus x. This is the same thing as this. In proving the mean and variance of a Bernoulli distribution, of course we have the mean P and variance PQ. So what we need to do is to prove the mean of this distribution. Let's prove if this is actually P. We have expected value of x is equals to summation of I equals 1 to 2 xi f of x. We need to substitute the value of our f of x, which is this, into this expression. We have xi, this f of x is the same thing as this, px q1 minus x. Of course, we know that our x ranges from 0 to 1. We have x1 because our I ranges from 1 to 2. x1 p raised to power x1 q1 minus x1 plus s2 p raised to power x2 q1 minus s2. All we need to do is to substitute this part as 0, substitute the value of x in this part as 1 because our x ranges from 0 to 1. So anywhere we see x here, we put 0. Anywhere we see x here, we put 1. We have 0 p raised to power 0 q 1 minus 0 plus 1 multiplied by p raised to power 1 q 1 minus 1 for x equals 0, 1. So all we need to do here is to multiply through by 0. Of course, 0 multiplied by this will give us 0. Multiplied by this will give us 0. Everything here gives us 0. We have 0 plus 1 multiplied by 3 to the power 1, we have p. Q 1 minus 1 will give us 0. Of course, mathematics, we know that anything to the power of 0 will give us 1. So we have 0 plus p. This gives us 1. Therefore, we have 0 plus p plus 1, which gives us p. So the mean of a Bernoulli distribution is p, in which we have here. When the mean of this distribution to be p, we need to verify as well that the variance of this distribution is pq. Let me flash our mind back to the formula for variance. var x is equals to expectation of x squared minus expectation of x all squared. This is the formula for variance. When we were solving for the mean of this distribution to be p, of course we solve for x. So what we need to do now is to solve for the expectation of x squared. So we have summation of I equals 1 to 2 s squared f of x, where I ranges from 1 to 2. So we need to put the value of f of x into this expression. So we have x pi q1 minus xi. For x is from 0, 1. So we have x 1 squared plus multiply by x 1 q1 minus x1 plus x2 squared p raised to power x2 q1 minus x2. for all x equals 0, 1, meaning that anywhere we see x in here we put 0, anywhere we see x here we put 1. So here becomes 0 squared multiplied by p raised to power 0, q raised to power 1 minus 0, plus when x equals 1, 1 squared p raised to power 1, q raised to power 1 minus 1. Of course, everything here becomes 0 because this 0 is multiplying through here with 0, which becomes 0, plus 1 squared multiplied by p will give us p, multiplied by q, 1 minus 1 will give us 0. Anything to the power of 0 gives us 1. Of course, we have 0 plus p multiplied by 1, which gives us p. Expected value of x all squared gives us p. So we've gotten the value of this. Initially, we know the value of this to be p as well when we were solving for mean. So we have var x is equals to p minus, when we solve for p in our mean, we got p as well. But don't forget, this is in squared. Let's collect the like terms. P can come outside, and I have 1 minus p. Yeah, because if I multiply p times 1 will give me p, and p multiplied by p, I have p squared. As you can see that in here we have p into brackets 1 minus p, and don't forget when I said 1 minus p can also be known as q. So since 1 minus p is equals to q, I have var s is equals to p q. Thank you. So in this video, we've solved for the mean of this distribution to be p and the variance to be pq. Thanks for watching. Like and subscribe.